Hi, Ivy. We're going to go into 15C, which is the product rule, and we are starting to deal with how to take the derivative of more complex functions, specifically when you identify your function as a product of two other functions. So we are going to use blue to show our U function and V as green to show our second function. So first we need to make sure we identify our function as a product. So if I were looking at this example of f of x, 4x squared, I would wind up identifying as my u, and 3x squared minus 7x quantity raised to the fourth as my v. Now, what the product rule says is that if we have a product of two functions, we can take the derivative of the first function, our u dashed, multiply by the original second function, and add that to the derivative of your second function multiplied by your original u. So first function. In other words, v times u prime plus u times v prime, or v times u dashed plus u times v dashed. Now for the product rule and also the quotient rule, which is coming up next, we do want to make sure that we actually set out our working before we begin to apply the product rule. So we want to make sure that we have some side work where we identify our u. So for us, this will be 4x squared. We can already take the derivative of 4x squared as 8x. And we'll do the same for our v function. So that will be 3x squared minus 7x, all raised to the fourth. And then v dashed. Notice, in order for us to take the derivative of v, I'm going to have to use the chain rule. So we might have to use rules within other rules now that we know how to take the derivative of different types of functions. So for this one, my chain rule tells me that I have inside function 3x squared minus 7x, all raised to the fourth power. So the 4 will come down, multiplied by my coefficient. Keep your inside function the same, raised to the third power, and then multiply by 6x minus 7. So once we have that, we can simplify this as 24x minus 28 if we multiply the 4 by the 6x minus 7. And I'm going to keep 3x squared minus 7x all raised to the third power. I'm not going to expand that because to the third power would be too much, but I can at least put together the 4 and the 6x minus 7. That might help me down the road. So if I can simplify any of these derivatives before I begin to apply the product rule, it would be very helpful. So let's go back now and actually use the product rule. So f dash, derivative of f of x, is going to be our derivative of u multiplied by the original v. So I'm going to take the derivative of u, which is 8x, and I'm going to multiply that by my original v, which is 3x squared minus 7x, all raised to the fourth power. I'm going to add that to the derivative of v, which I've now simplified down to 24x minus 28, multiplied by 3x squared minus 7x raised to the third power. And I multiply that by my original u, which is 4x squared. At this point, I have the derivative. So this expression here is the representation of the derivative of f of x. If I can clean this up at all, what I might do is notice that I have common factors. So 3x squared minus 7x and 3x squared minus 7x. I could wind up taking out 3x squared minus 7x to the third power. So if I did that, 3x squared I can factorize to the third power, and then I'm left with this 8x multiplied by 1 remaining 3x squared minus 7x, plus I would have the 24x minus 28. I've taken out the 3x squared minus 7x to the third power, so I have 4x squared remaining. Oh, so now I've got this long string that can be expanded and simplified. For the most part, again, we're keeping track of our terms. We'll practice in class how far to simplify, but try to reduce just as far as you can correctly without taking away time from your other questions. So never anything more than I would say if you have something cubed or to the fourth power, anything higher than cubed or cubed, I would keep it factorized. this right here could be multiplied out and simplified, so we can definitely do that. Just for practice, go ahead and pause and try to simplify this down. So for this particular example, it is worth it to simplify. It does wind up looking a lot nicer and neater when you guys wind up at least combining this string of terms. But again, we'll practice in class with how far we'd like to simplify. For the second example, I'm going to set you guys up, and then let's go ahead and pause the video so you can practice this one on your own. So again, we notice that we have a product, therefore we can use the product rule. So the first step is, of course, identifying which rule we need to use here. Let's identify your u as 1 over 3x plus 2. Now I know that I'm going to have to rewrite this in order for me to take the derivative. So automatically, I should rewrite my u as 3x plus 2 raised to the negative first power. So therefore, when I take the derivative, I'm using the chain rule. Negative 1, 3x plus 2 stays the same. Drop 1 from the exponent, so now I'm at negative 2, and then multiply by the derivative of the inside. Clean that up a bit, so 3 and negative 1 will stay in the numerator. And then your 3x plus 2 is now squared in the denominator. We'll do the same for v, is 4 square root of x. So again, I have to rewrite that as 4x to the 1/2 power so that I can take the derivative. 1/2 times 4 is 2x. Drop 1 from the exponent, so now I'm at negative 1/2. And let's clean that up. The 2 stays in the numerator, and square root of x is now my denominator. Once I have those identified, let's go ahead and use the product rule. So go ahead and pause here, set up, and try to simplify as much as you can. Let's see how we do. Go ahead and check that you substituted correctly. And just check that your answer actually matches. Have a good night, guys. See you next time.